Welcome everybody. We're going to pick it up where we left off. So looking at separation of variables, we're really focusing in section 6.03 at this point, where we are really playing with these. We're going to start with some simpler ones. This is section 6.03, and then we're going to build in this more difficult one. So let's start with, I think 6 is a keeper. Let's do 5. Y equals dx over 2 plus x. I divided this way and I multiplied the dx up. To make your life easy, take the 1/3 out, and then you have dy over y equals dx over 2 plus x. That way, as you take the antiderivative, you get 1/3 of natural log of y equals natural log of 2 plus x. If I were to move that inside, I have natural log of y to the 1/3 equals natural log of 2 plus x. Exponentiate both sides. Oh, guys, what did I miss? Plus c. Sorry about that. Now I exponentiate both sides, and so I get e. So natural log of y to the 1/3 equals e natural log 2 plus x plus c, which on the left side it just cancels. I have y to the 1/3. Right side, I have natural log of 2 plus x, then that's plus c, so I have e to the natural log of 2 plus x times e to the c. So I have y to the 1/3 equals 2 plus x times e to the c, which is just c. So I have y to the 1/3 equals c times 2 plus x. So I have y equals c times 2 plus x to the third. People are upset usually. I get calls all the time saying, but I cubed c. You did. So remember, though, c represents all constants, and so if I cube all constants, I just have more constants. So you just leave it as c. If that's wrong, please send me an email. Number 6 looks pretty similar, but 6 is x times dy dx equals y. So dy over y equals dx over x, which is natural log of y equals natural log of x plus c. So I have exponentiate, I get e equals e to the natural log of x plus c. So I have y equals e to the natural log of x times e to the c. So I have y equals x times c. And that makes sense if you were to go back to this of thinking about how that looks like that. Just throwing it out there. Nicely done. All right, guys. Now we're going to look at some more difficult ones. So let's. I like 11. I like them all. I say we do 11 and 12. So let's start with 11. So I got y times natural log of x minus x times y prime. So first thing I need to do, if I want to deal with that dy dx, I need to get it so I can actually multiply it. So, right. So I now have my dy on top on the right side. So I'm going to get all my y's to the right and all my x's to the left. So the only y I got to move is that one. So I've got dy over y on the right. On the left, I've got my dx. And then I have my natural log of x that was still there. And then I have this guy, right? I got x on the bottom. Excuse me. And so right side is easy to find the antiderivative of. You got natural log of y, okay? But the left side, this is where it gets fun. You get to do a u substitution. So if you were to say u equals natural log of x, du would be 1 over x dx. 1 over x dx, you're looking at it right here. And so really what I have is I have u times du. Well, if I find the antiderivative of that, I add a power and divide by a power plus c equals natural log of y. Now I need to plug back in, right? Now I have to exponentiate And so I get y. I have e to the 1/2 of natural log of x quantity squared plus c, so really it's just a c in front. And there I am. Very common, very good problem. Okay. I hope that helps. One of the things that I think I might have gone too fast on is that u substitution. Recognizing that natural log of x, the derivative is 1 divided by x. And so I can do that u substitution. Remember, you always got to come back to those u substitutions. So you're going to use them. You just got to be willing. If you're like, natural log of x over x, I can't do that. Could I do a u substitution that could, the derivative of one of them will get me the other one out of there. So let's do this one on the right. I think this is a really good one. So we've got, first we need to get that y prime solo. So I'm going to move this over. This is going to be fun. All right, you see that e to the x. Life should be good. And so I get my dx to the right. So I've got y dy, 4 still there, sorry, equals 3 e to the x dx. If I could cancel those 3's and 4's right now, I would. So just to let you know, that's my thought. So take the antiderivative, I get 4 times 1/2 y to the 1/2. Y squared. Sorry. Equals, let's see, the antiderivative of e to the x is still e to the x. Right, it's not that bad, actually. And so you get 2y squared equals 3e to the x plus c. Okay? I say we do 10. So guys, we're going to be looking at number 10 here. So 10. So I've got square root of x squared minus 9 times dy dx equals 5x. Well, I need to get my x's and dx's on one side. So I've got dy equals 5x dx over square root of x squared minus 9. Here's what I'm thinking. I've got an x squared on the bottom, I got a 5x on top. But what's the derivative of x squared? That x up there. So I need to do a u substitution because we're going to use the idea that a derivative of one of the things helps me. So u equals x squared minus 9. So du equals 2x dx. Since I see it over there, I see an x dx. I'm going to solve this for x dx. So I get du over 2 equals x dx. So I'm going to rewrite what I got. Dy equals 5 x dx over square root of u. X dx equals du over 2. I'm now going to rewrite this. So I've got 5 halves. I have my du, and I have my u to the negative 1/2. And so y equals 5 halves, add a power, divide by a power. If I divide by 1/2, that's the same as multiplying by 2, plus c. And so I have y equals 5 u to the 1/2 plus c. Y equals 5 u. Well, what's my u? My u is x squared minus 9. All right, now so let's take this one on right here. So we're going to do number 15. Here we go. So I start by saying I'm going to get my y prime to the other side. So negative dy dx to this side. There's an x plus 1 here. So I'm going to move my dx this way. Dx times x plus 1 equals, let's move that over. So I get negative dy over y. And so if I take the antiderivative of this, I get x plus 1 quantity squared plus c equals negative natural log of y. Now, negative, I don't want it on the natural log side. So I'm just going to just get that out of there. And so I have negative x plus 1 quantity squared plus c. need to exponentiate. So I get y equals e to the negative x plus 1 squared plus c. Now, I'm going to rewrite that, though, as c times e to the negative x plus 1 quantity squared equals y. Now, I take my initial condition, y of negative 2 equals 1. So c e to the negative 2 plus 1. So c e to the negative, let's see, negative 2 plus 1 is negative 1 squared is 1. So c times e to the negative 1 equals 1. So c equals e to the 1. So now I have e to the 1, e to the negative x plus 1 quantity squared equals y. And so I have e to the negative x plus 1 quantity squared plus 1 equals y. There you go. I hope that helps. Another good one is 16, because if you notice, you have a natural log of x squared, and you've got that 2x. So when you get them over, you're going to have to do a u substitution with that. It's a great problem to do. All right, guys. Have a great day. Thanks for tuning in.